first. We need to determine the velocity of point C and also the angular velocity of rod BC. So as you can see here, we have two rods in this case, which is AB. This is one rod, and another rod is BC. Okay, so point A is the fixed point. Point B basically rotates about point A. This is the trajectory of point B moving around point A, because AB is rotating in anti-clockwise direction, and point C will therefore move left and also right, left, right, depending on the rotation. So clearly this side here, AB, will be the rotation part. Okay, so we can write here AB is the rotation, and BC is basically the general plane motion part lah. Okay, so AB is rotation and BC is the general plane motion. So what we want to find here is the VC, velocity of point C, as well as the angular velocity of rod BC, which is omega BC. Okay, so let's start with the first one. So the first one, we need to draw the position vector. So as I mentioned earlier, the position vector, let me erase this first. Okay, so the position vector is basically for the first one, it will start from the fixed point, so going from A to B. So this is the first position vector, and we can call this as RB/A. This is the first position vector. And the second position vector, it has to start from point B pointing to C. Okay, so this one will be RC/B. So that is the position vector. Okay, so we know that rod AB is rotation, and rod BC is general plane motion, although the equation requires us to calculate VC, but we need to calculate the rotation first. Okay, so by looking at this figure here, we should know that the direction of velocity of point B, VB, must be pointing in this direction. Okay, must be pointing in that direction. This will be VB. Why? Because it is 90 degrees. Okay, it is 90 degrees to the position vector RB/A, or it is actually tangent to the path lah. Okay, tangent to the path of point B. So as we indicate earlier, point B is traveling in a circle with point A as the center of the circle lah. So this basically is the path of point B traveling around a circle. So VB is basically tangent to that path, or 90 degrees to the position vector RB/A. Okay, so to solve this problem, we need to calculate VB first. Okay, so as we know, for rotation, we write the equation VB, okay, is equal to omega cross product R. So omega here is omega AB, okay, cross product RB/A, and everything has to be in vector form where you have the arrow on top lah. Okay, so to get VB, we need to find or we need to know what is omega AB and what is RB/A. Okay, so let's start with omega AB, the easiest one. Omega AB, a vector. Now we need to write this in unit vector form. Okay, in unit vector, it is given that omega AB is 3 radian per second in anti-clockwise. Therefore, it is positive. So omega is always in K unit vector. So we write it as 3k with the unit of radian per second. Okay, so that is the first part. Now the second part is we need to get RB slash A. Okay, so RB slash A. So if we zoom in here, we can see that RB slash A is diagonal. So what we need here is to find the X and Y component. So as usual, the X component will be positive to the right, and the Y component is positive pointing up lah for this problem. So when we zoom in, we need the X component to make a triangle out of this. X component is pointing in this direction to the right, which will be positive, and the Y component should be pointing upwards, which is also positive. So this will be the I component and this will be the J component. Okay, so we have the angle of 45 degrees. We know the distance of AB, which is given here 0.5 meters, so we can use that. So what we write here will be is equal to, the I component is positive, so 0.5 cos 45 degrees I, and also plus the Y component is also positive, which will give you 0.5 sine of 45 degrees J. Okay, so we can write this down as 0.3536I plus 0.3536J. So 0.3536I, okay, plus 0.3536J. The unit is in meter. Okay, so notice that when you have a diagonal vector, then the value will be will have two components, I and J component. Okay, so we have this. Then we can proceed by to solve this equation lah. VB, to get the value of VB. So we write down the equation again. VB is equal to omega AB is now 3K, and then cross product, okay, RB slash A, we put it in bracket, 0.3536I plus 0.3536J. Okay, so to solve this, as we have learned before, the first one is to multiply the value. So the first value is 3 and 0.3536. Okay, 0.3536. So what we will get when we do multiplication here is we get 1.0608. Okay, 1.0608. The second part is to do vector multiplication of K and I. Okay, to do this, as we discussed in the class before, we will write I, okay, going to J in the anti-clockwise direction. So this is J, this is I with the head, J with the head, J going to K, okay, anti-clockwise, and then K going to I, also anti-clockwise. So what we have here is basically K cross product I. So this motion is also anti-clockwise lah, K going to I. So what we will get is positive J. Okay, we will get positive J. So here you can write it down as positive J. This is what we get out of K cross product I. The second part will be now 3, okay, multiply with another 0.3536. That will give you the same value. So this will be again plus 1.0608. Okay, 0608. And the second vector multiplication will be K cross product J. Okay, so we go back to the to this. So now it is K, okay, and to cross product J, it will go the other way around, which is clockwise. Cross product J, now it will give you the negative value of I. Okay, so what we get here is negative I. Okay, so finally we can write down VB is equal to, you can write I first if you want, minus 1.0608 I, okay, and then plus 1.0608 J. All right, the unit for velocity is meter per second. Okay, how do we check that this answer is correct? So this is the first value. This is not what we want to find yet, but this is the first important value to proceed with the calculation. How do we check whether this is correct or not? We look at this velocity direction here. This is what we have determined earlier, that VB is diagonal pointing upwards to the left. So if we resolve this into components, so what you will get is, you will get a negative I to make a triangle here, and you will get a positive J. So the expectation is VB, the answer should be negative I and positive J. So we go back to our answer here, and we get indeed negative I and positive J. So we know that the answer should be correct. Okay, so that is the first part, which is VB. This is the rotation punya part lah. So this is rotation calculation. Now we move on to the second part, which is the BC. Okay, BC here. BC is gonna be general plane motion. Okay, BC is general plane motion. Why? Because point B is rotating around A, and point C is moving left and right, translation. So you have a combination. In this rod BC, one end is rotation, the other end is translation. That's why this is general plane motion. Okay, so this is BC is general plane motion. All right, so now let's write down the equation. This is what we want to calculate, which is VC. Okay, so what is the equation that we learned before? VC, okay, vector, I will zoom in here. Okay, when we want to calculate for general plane motion, remember, it has to refer to another point. So now we are focusing on here, VC. You will need to refer to the other point that is on the same body, which is VB. So VB we have calculated before. So now the equation will be VC is equal to VB. Okay, VC is equal to VB plus, now we go back to the rotation punya equation. So now omega, but it is not omega AB, but it is omega BC. Okay, omega BC, because we are calculating now the rod BC. So omega BC, and then cross product the position vector R, but it is not RB slash A, but it is RC slash B. Okay, RC slash B. Okay. And before we proceed, if we look at this this figure here, when AB is rotating anti-clockwise like this, what will happen to point C? Our expectation is that point C will move to the left. So this is our expectation of the direction of velocity VC. So we're gonna draw the velocity vector of point C pointing in that direction. So this will be VC. So we should expect later our answer for VC will be negative I, okay, because it is in the negative direction of x-axis. Okay, so this is our formula here, our equation. To get VC and omega BC, we need VB. We already have VB, which has been calculated here. So now what we need to find first is probably RC slash B. So this is easy. RC slash B, if you look here, is basically from point B to point C. pointing to the right, and the length is 1.5 meters. So pointing to the right is positive x-axis, and the value is 1.5 meter. So we can write RC slash B. RC slash B is basically 1.5 I positive. The unit is meter. Okay, and then we need to convert everything basically into unit vector form. So now VC, we need to also convert this into unit vector. So as expected, VC is pointing to the left, so that will be negative I. So we just write down minus VC because the value is unknown, minus VCI. Okay, and then omega BC. Omega BC is also unknown, so we're gonna write this as omega BCK. Omega BCK. Okay, so now everything is has the value in unit vector form together with VB that we have calculated down there. So we can then rewrite this equation again. Rewrite this equation again in unit vector form. So VC becomes negative VCI, okay, equal to VB is minus 1.0608 I plus 1.0608 J, that is VB. And then moving on to here, omega BC plus omega BC is omega BCK, and then cross product RC slash B is 1.5 I. Okay, so the first thing to do, as we did for the first tutorial, is to solve the vector cross product multiplication. Okay, so here we will do the same thing like what we did before. First is to multiply the value omega BC and 1.5. So what we will get is 1.5 omega BC. And then we have the cross product of K and also I. Okay, so we go back to our vector multiplication again, unit vector multiplication. I going to J in anti-clockwise, J going to K in anti-clockwise, and K going back to I. So what we have here is basically K cross product I. So that is basically in anti-clockwise direction. So we will get J that is positive because it is anti-clockwise. So we have here positive J. So we can write down J here. Okay, so once we have all this, we will identify the unknowns and put them together on one side. So the unknown here is obviously omega BC. This is unknown, and also VCI. So we can bring this to the left hand side together with VCI. So you will get minus VCI, and then 1.5 omega BCJ, bring to the left, it will be minus also, minus 1.5 omega BCJ. Okay, and then equal to what we have on the right hand side, which is the value minus 1.0608I plus 1.0608J. Okay, now the final step is to sort them into I and J component. Okay, I and J component. So let's look at the I component for VC. So we have minus 1 here, minus 1 VC, and we do not have omega BC for I component. And on the right hand side, we have minus 1.0608 I. So from here straight away, we can get the value of VC. VC is equal to negative and negative will cancel out, is equal to 1.0608 meter per second. That is our VC. And then for J component, we do not have J component for VC. We have minus 1.5 omega BC is equal to 1.0608 for J component, and therefore omega BC will be will be 1.0608 divided by minus 1.5, which will give you minus 0.707 minus 0.707 radian per second. Okay, now I want to, this is our final answer. You can leave it like this, your final answer. But now let's focus on why do we get a negative value for omega BC. Okay, so going back to here, initially, when we write down omega BC as omega BCK, we actually assume that this rod BC is rotating anti-clockwise also. This is our assumption of omega BC. That is why we write it down as omega BCK. Omega BCK as positive. Okay, this omega BCK positive is basically assuming that omega BC is rotating anti-clockwise, because in rotation, remember, anti-clockwise rotation is always positive. But when we actually get a negative value, it means that our earlier assumption that rod BC is rotating anti-clockwise is not correct, but actually rod BC is rotating clockwise. Okay, and rod BC is basically rotating clockwise, but you can just leave it like that. When we see negative value of omega BC, we can know straight away that rod BC is basically having a clockwise rotation.